everyone, welcome back for the third instalment of numerical integration techniques. So we've looked at left-hand rectangles, we've looked at right-hand rectangles. Now it's time to get a little bit more accurate, and this one's probably the easiest of the lot. So a lot of the preliminaries we've already done will still apply. We will still use this function. We will still have three little rectangles, or three little sections between a lower limit of 2 and an upper limit of 5, and we would still designate the first x value as x0, x1, x2 and x3 for our case, but in more generally xn. Now we saw when we used the lower rectangles, so if I sort of colour in the lower rectangles yellow, and I'll go and put a little top back on those. So if I did use the left-hand rectangles, we saw that that area came to 26.7 square units, and that's the lower limit, or the left rectangles. With the upper ones, so if I was to the entire thing there, in green. If I copy over the top, it'll go green, won't it? Yeah, so that'd be silly. Now, we saw with that one was 39. Yes, 39.0 square units. And of course, we realise that the true value of the area is somewhere in between these two numbers. Now, could we do a better approximation? The answer is yes, we can do a better approximation. So I'll let you think for a minute. If I was to make a straight line between each of these points, so in other words, a trapezium, the trapezium shape would actually be, for each rectangle, the trapezium would be halfway between the yellow and the green areas. And that's what we call the Trapezum Rule. So the Trapezum Rule, we could calculate the area, it's approximate still, but it would be the left-hand sum plus the right-hand rectangles divided by 2, as straightforward as that. And using our numbers, 26.7 plus 39.0 divided by 2. So we'll just, I don't trust my head to do that one, so let's just go to the calculator. Here we go, 26.7 plus 39 all divided by 2, and we get 32.85. 32.85 square units. Now, that's a better approximation, and it's a very straightforward calculation. Now, what I'd like to do is just use the calculator on the graphing screen. There it is, graph the function, and I'm going to get the calculator to do the integration for me. Here we go. From the lower limit of 2, and the upper boundary is 5, and it says 32.7. You can see that our answer is still not perfect. It's close though, and it's much closer than the left or the right sum, and we only use 3 rectangles, or in this case 3 trapezium shapes. So that's pretty good when you consider how rough our diagram was. Had we used a greater number than 3, I think we would have had a very accurate result. And it's nothing more than calculating heights of rectangles and areas of rectangles. And for a trapezium, well, there is a slightly more complicated version of the Trapezum Rule, but for now, this is enough. It's the average of the left rectangles and the right rectangles. And I think that'll do for today. Thanks for watching.